Hello guys, welcome back to this video. Let's start learning about CPU, GPU and other processes. So before we start, let's just start it instead of introducing to the video. So let's start. What do you mean by GPU and CPU? What do you mean by CPU at first? Well, CPU means Central Processing Unit, and it is like the brain of the computer, and it handles all the general purpose tasks and coordinates the different parts of your system. It is like a manager who assigns tasks and ensures everything runs smoothly. So in this modern era, we have like a lot of cores, like 16 cores and 12 core, or even more than 16 core. But we used to have only one core a few years back. And let's start talking about core. A core is a single processing unit within the CPU. Every CPU has at least one core, meaning they could only handle, the early CPUs, okay? The early CPUs has only one core, and every CPU has minimum one core, and the early CPUs can only handle like one task at a time. Single core process can only process one task or thread at a time, and dual core has two core, so it can handle two tasks simultaneously. Quad core can handle 4 core, enabling even more multitasking. And clock speed. What do I mean by clock speed? Clock speed is measured in gigahertz or GHz, and its example is like 3.5 gigahertz. You can see it in minimum requirement of certain softwares, and it indicates how fast the CPU can process tasks. Higher speeds generally mean better performance. And then there is GPU. GPU is usually very much related to gaming. So it's used in certain softwares used for animation and video graphics actually. And GPU means graphics processing unit, and it specializes in handling large scale computation, especially those needed for rendering graphics. Think of it as artists that draws images, animations and videos. Parallel processing power. Unlike CPUs, GPUs have hundreds of thousands of cores designed to work on a smaller task at once. This makes them perfect for rendering video games, running simulations, processing data in AI and machine learning. So why do we have a lot of cores? Because GPUs break a task like drawing pixels on your screen into many smaller pieces and process them all at once. For instance, if you are playing like a game at 4K resolution, the GPU manages millions of pixels simultaneously. So comparison between CPU and GPU. CPU used for general computing task, GPU for specialized parallel task, and CPU has only few cores and GPU has hundreds to thousands of cores. And CPU is very fast, GPU is slower but massively parallel. CPU office work, programming, browsing, etc. And GPU for gaming, 3D rendering, AI training. Talking about programming, sometimes you may need like really good GPU to do programming as well, not just good CPU, because in some video games development we need to render high graphics. Now let's talk about single core and multi-core. Now single core means only has one core to process data, and it's good for simple tasks, example old school word processing and lightweight software. Modern systems rarely use single core process anymore, and multi-core can perform multiple tasks simultaneously. Dual core has 2 core, quad core has 4 core, and octa core and beyond. These are used for high performance tasks like gaming, video game and simulations. I'm talking about octa-core and beyond. And quad-core can also be used, and dual-core can be used for basic multitasking. Why do we need both CPU and GPU? Well, the CPU is used for making decisions and delegating tasks, and GPU is used for highly repetitive tasks with efficiency. When playing a game, the CPU decides what should happen, like character moves, and then the GPU draws the graphics in the game. And fun fact, GPUs in AI, GPUs are essential in training artificial intelligence because they can process vast datasets much faster than CPU. And integrated versus dedicated GPUs. Integrated GPUs are built into the CPU and are good for everyday tasks. Dedicated GPUs are separate and much more powerful, ideal for gaming or heavy computations. So integrated GPUs are built into the CPU and are good for everyday tasks. Dedicated GPUs are separate and much more powerful, ideal for gaming or heavy computations. So that's it, guys. Now that's the basics of GPU, CPU, and other processors. And there are other processors as well, but we do not have to learn about that much. For example, TPU, Tensor Processing Unit by Google, NPU, Neural Processing Unit for AI computation, and then there are microcontrollers and quantum process. Quantum process utilizes quantum mechanics to perform computation far beyond the capabilities of classical process, and it's used for solving complex optimization problems, cryptography, and secure communication, simulating molecular and physical systems, and operates using qubits, which can represent multiple states simultaneously. So it's like having two of those bits together, and it's really fast, so you can do computation which are really complex using quantum process. So that's one of the important process. So that's it, guys. So thank you for watching the video, and do not forget to subscribe, and yeah, thank you.